In 1936, the Rural Electrification Administration was established by executive order to extend America's power grid to every farmhouse and rural community in the country. And the language used to sell it was about progress, about modernity, about bringing civilization to the dark. What that language never mentioned was the financial architecture underneath. A system built on metered consumption, on monthly billing, on the foundational premise that electricity is something you buy from someone else permanently for the rest of your life. The technology to generate usable electricity from heat, any heat, a candle flame, a wood stove, the exhaust off an engine, had already existed for over 115 years by the time that executive order was signed. Thomas Johann Seebeck had discovered it in Berlin in 1821, published his findings in the Proceedings of the Royal Prussian Academy of Sciences in 1822, and the physics had never failed once since then. You cannot build a $46 billion annual utility industry, according to Grandview Research's 2022 Power Generation Market Report, on something a person can build for $15 and never pay for again. That is not a suppression. That is math. A $15 thermoelectric generator built from 2 Peltier modules and a $2 boost converter produces real, usable phone charging electricity from any heat source, a candle, a wood stove, a campfire, indefinitely with 0 moving parts, 0 fuel cost, and 0 permission from anyone. There is one mistake almost every first-time builder makes with this. A mistake so fundamental that the module produces almost nothing at all, which is exactly why most people who have heard of this conclude it is a science fair trick and not a real system. That mistake is in the cold side, not the wiring, not the heat source, the cold side. Every person who tried this and walked away disappointed made the same error in the same place. We are going to name it before we do anything else, and when we do, the whole system will make sense in a way it probably hasn't before. The global power generation equipment market was valued at $46 billion in 2022, according to Grandview Research. One sentence. Move on. Thomas Johann Seebeck was a physicist of Estonian origin working in Berlin when he made the discovery that would eventually power Voyager 1 to the edge of the solar system. In 1821, while studying the relationship between heat and magnetism, he constructed a circuit from 2 different metals, bismuth and copper, joined at 2 points and held one junction warmer than the other. A compass needle placed near the circuit deflected. He initially called it thermomagnetism because he didn't yet understand that what he was observing was electrical current produced by a temperature difference. He was corrected within a few years by the broader scientific community, and the effect was renamed for him. The Seebeck coefficient, the ratio of voltage produced per degree of temperature difference in a given material pair, is still measured in units of microvolts per Kelvin today in every semiconductor laboratory on Earth. Jean-Charles Athanase Peltier, a French physicist and watchmaker, demonstrated the reverse effect in 1834, that running electrical current through the same kind of bimetallic junction would produce a temperature difference rather than consuming one. That discovery meant the relationship between heat and electricity in these junctions runs both directions. Cool one side electrically, or heat one side physically and extract electricity. The same device, the same physics. The science was settled and published in European academic journals before the American Civil War. It has not changed since. The Romans did not have the vocabulary for what they were observing, but metallurgical records from Pompeii document anomalous behaviors in iron and copper junctions near forge fires, deflections, currents they attributed to spiritual forces. The phenomenon was real. The explanation was 2,000 years premature. Seebeck gave it the name, the Romans gave it the first sighting. NASA formalized it into engineering. The SNAP-3 radioisotope thermoelectric generator flew on the Transit 4A navigation satellite in 1961 under the Systems for Nuclear Auxiliary Power program. It used the Seebeck effect to convert heat from a radioactive decay source into electricity with 0 moving parts. Every deep space mission that traveled too far from the sun for solar panels to be viable has relied on this exact physics. Pioneer 10, launched 1972, Pioneer 11, launched 1973, Voyager 1 and Voyager 2, both launched 1977. Cassini, launched 1997. New Horizons, launched 2006. Voyager 1 is currently more than 23 billion kilometers from Earth, according to NASA's Jet Propulsion Laboratory real-time tracking data. Its thermoelectric generators are still producing electricity. That spacecraft has been running on this effect for 47 years, with no refueling, no maintenance, and no grid connection. That is not a metaphor for the technology. It is the specification sheet. You cannot build a recurring revenue model on that. You cannot meter a temperature difference. You cannot charge a monthly fee for the gap between a hot surface and cool air. The utility grid was not built primarily as an engineering solution after about 1945. It was built as a billing infrastructure. The engineering had largely been solved. What remained was the contractual relationship between a household and a provider, extended indefinitely through inertia, convenience, and the complete absence of any reason to tell you there was another way. You have seen this your whole life and simply never put the name on it. The back of your refrigerator is warm, the inside is cold. That thermal differential is the Peltier effect operating in reverse. Electricity in, temperature difference out. Instead of temperature difference in, electricity out. The copper heatsink bolted to the processor in your computer exists for one reason. To manage the same physics we are about to harness on purpose. The mist that forms on a cold glass of water on a hot day is the atmosphere responding to a differential. Every campfire, every candle, every wood stove, every engine exhaust pipe is a one-sided thermal gradient begging for a cold surface on the other side. The differential is the engine. You do not need a special fuel, you need a difference. The mistake that kills this build lives in the cold side. Not the wiring, not the module orientation, not the solder joints. The cold side. Hold that in your mind as we walk through what you need, because by the time we reach it, you will recognize it immediately. Here is what you need. I want to be straight with you about every number. 2 TK1 and 12706 Peltier thermoelectric modules. These are the standard 40mm by 40mm devices used in everything from portable camping coolers to CPU cooling experiments to laboratory thermal cyclers. The designation tells you their rated operating parameters, 12 volts, 6 amps at maximum differential, but you are not running them as consumers. You are running them as generators, which means you are operating them well below their rated specification, and that is fine. Pricing. Approximately $2.50 each from AliExpress or eBay with standard shipping, or $4 each from Amazon for faster delivery. Total for 2 modules, $5 to $8. 1 DC to DC boost converter module with USB output. Search for MT3608 USB boost converter or 0.95 5V step-up module USB. This component takes the low variable voltage that your modules produce, often between 1 and 5 volts depending on differential, and steps it up to a stable 5 volts at the USB port. It costs approximately $2. It is the component that turns a physics demonstration into something that charges a phone. 1 passive aluminum CPU heatsink, the kind without a fan. If you have an old desktop tower in a closet or a garage, the heatsink on that processor is likely a perfect fit and costs you nothing. If not, a small generic passive heatsink is under $3 on any electronics parts site or Amazon. Thermal paste. Most people who have ever opened a computer already own a tube. If not, it is under $2 anywhere that sells computer accessories. You need a small amount, a pea-sized application per module. 2 short lengths of hookup wire, 22 or 24 gauge. Already in most households with any electronics background. If not, a small roll is under $2 and will last you through a dozen other projects. That is $12 to $15. Genuinely it. No soldering iron required for the basic build. The Tech A modules ship with wire leads already attached. No special tools. No workshop required. A kitchen table works. Here is the one thing most people get wrong. When you place a Peltier module with its hot side down against a heat source, a candle in a metal holder, the top plate of a small alcohol burner, the surface of a wood stove, the hot side heats up rapidly and correctly. The first 30 seconds feel exactly right. What happens in the following 60 seconds is where the build either works or dies quietly and wastes your afternoon. Heat conducts through the module. Both sides of a Peltier module are thermally connected through the ceramic substrate and the bismuth telluride semiconductor elements sandwiched inside it. If the cold side has nothing to carry that heat away, if it is simply exposed to still air, the entire module equalizes. Hot side, 80 degrees. Cold side, 75 degrees. Differential, 5 degrees. Voltage output at 5 degrees differential on a Tech 1 12706. Nearly zero. The module is working perfectly. The physics is working perfectly. You gave it no differential to work with. Think of a water wheel. The wheel turns because water on one side is higher than water on the other side. The moment both sides reach the same level, the wheel stops. Not because the wheel broke, because you took away the thing that made it turn. Temperature differential is your water level difference. You eliminate it, and you eliminate everything. The fix is one component and one technique. Take your aluminum heatsink and apply a thin, even layer of thermal paste to its base, just enough to fill the microscopic surface imperfections. Not so much that it runs or pools. Press it firmly against the cold side of your first Peltier module. Hold it with light pressure for 30 seconds. You will feel the heatsink warming as it begins drawing heat away from the module surface. That is correct. That is the system working. The heatsink's purpose is not to stay cold. It is to carry heat away from the module surface faster than conduction through the ceramic can deliver it. Surface area is the mechanism. More fins, more surface area, more heat carried into the surrounding air. For a candle heat source, A standard CPU heatsink and still air is sufficient. You will see a differential of 30 to 50 degrees Celsius between the hot and cold sides, which produces approximately 1.5 to 3 volts per module. Wire your two modules in series, positive lead of the first to the negative lead of the second, and you double that to 3 to 6 volts at the combined output. Connect those leads to the input terminals of your MT3608 boost converter, and it handles the rest, stepping the variable input up to a stable 5 volts at the USB port. For a wood stove or alcohol burner, where surface temperatures run higher, between 150 and 300 degrees Celsius on the hot side, you will want to supplement the heatsink with passive water cooling. Rest the fins of the heatsink in a small metal tray holding a centimeter of room temperature water. Water conducts heat away from a surface approximately 25 times faster than air, according to the thermal conductivity tables in the Handbook of Heat Transfer, 3rd edition, edited by Rosenow, Hartnett, and Cho. The differential on a wood stove surface with water cooling on the cold side can reach 150 degrees Celsius or more, producing 5 to 8 volts per module before the boost converter, and current sufficient to charge a standard smartphone at roughly half the speed of a wall charger. The smart test requires nothing extra. Press 2 fingers gently against the top of your heatsink while the system is running. It should feel warm, not hot. Warm means the heatsink is doing its job, absorbing heat from the module and dissipating it into the air or water faster than the module can deliver it. If the heatsink feels hot to the touch, the cold side is losing the race and your differential is collapsing. In that case, add water cooling or direct a $2 USB fan at the fins, powered, if you like the irony, by the output of the generator itself once it is running. Check output at the USB port with any USB voltage meter, under $2, before connecting anything you care about. You're looking for 4.8 to 5.2 volts on a stable heat source. Once you see that number and it holds steady, the system is producing real, usable electricity from heat you are already generating. Now extend the picture outward and let the math do what math does. One candle and one dual module setup produces enough power to run a small USB LED lamp for the duration of the candle burn, 4 to 6 hours, and to maintain a slow charge on a phone battery overnight. That is a documented output range based on the TEX 1-12706 published specification data and reported measurements from the experimental electronics community on forums, including EEV blog and Instructables, where builders have posted multimeter readings under controlled conditions since at least 2013. 4 modules in series parallel configuration, 2 pairs in series, those pairs wired in parallel, doubles both voltage and current headroom. Under $40 in components. That configuration running off a small wood stove produces 5 to 10 watts of continuous electrical output, sufficient to run a dedicated 5-watt LED work lamp indefinitely, charge 2 devices simultaneously, and power a small FM radio receiver. On a stove, you are already burning for heat in a cold month. That electricity costs you nothing beyond what you already spent on firewood. 8 modules, still under $60, and you are producing ambient room lighting from a single wood stove burner with enough remaining output to run a small 12-volt battery charging circuit, giving you stored power for the hours when the stove is not burning. The modules scale in a straight line. The physics multiplies cleanly. The recurring cost remains 0. There is one more thing about this system that real-world builders took years to discover, something that changes where you deploy it entirely, and has nothing to do with the modules themselves. It surfaces in the closing. A household in the United States pays an average of $1,500 per year in electricity bills, according to the U.S. Energy Information Administration's 2023 Residential Energy Consumption Survey. That is a payment with no terminal date. It does not end when the house is paid off. It does not end when the appliances are paid off. It ends when you stop using electricity, which is to say, it does not end. A $15 thermoelectric generator does not replace that annual payment entirely. Nothing you can build for $15 replaces a grid connection at full household scale. Say that clearly and honestly. What it replaces is the baseline. The lights that matter when the grid fails, the phone charge that is the difference between isolation and contact, the small radio that tells you what is happening in the world outside your window. FEMA's official household preparedness documentation recommends a minimum 72-hour independent power capacity for every household as basic emergency readiness. 72 hours? This system meets that specification from a wood stove you are already burning for $15 and 0 recurring cost. A Peltier module with no moving parts, no bearings, no brushes, no combustion chambers, no seals, carries a rated operational lifespan exceeding 200,000 hours under standard industrial conditions, according to technical documentation published by bismuth telluride module manufacturers, including Hebei IT and Laird Thermal Systems. 200,000 hours is 22 years of continuous operation. There's nothing to maintain, nothing to replace, on any predictable schedule, and no consumable that depletes. Build it once. Use it as long as you live in that house. Now hear the honest limitation. This system does not power a refrigerator. It does not run a microwave, a well pump, an electric water heater, or a central air system. The thermodynamics of a 40-millimeter junction area will not produce kilowatt-scale power regardless of how many modules you add, because at some point the constraint is surface area and material properties, not intention or design. What this produces is 2 to 20 watts depending on configuration, which is lights, communication, and small electronics, nothing more. If you go into this expecting a whole house generator, you will be disappointed, and you will be wrong to be disappointed, because that is not what this is. What this is, specifically, exactly, without embellishment, is a zero recurring cost emergency power source for lighting and communications that runs off heat you are already producing, built for $15 with a 20-plus year service life. That is a precise and valuable thing. Do not ask it to be something it is not. The thing that field builders eventually discover, the deployment that changes the economics completely, has nothing to do with the workbench setup. It is the stovepipe. The outer surface of a standard 6-inch single-wall steel stovepipe during normal wood stove operation runs between 300 and 500 degrees Fahrenheit, according to clearance specifications published in NFPA 211, the National Fire Protection Association's standard for chimneys, fireplaces, and venting systems. That is a continuous, passive, no additional fuel heat source that exists every evening from October through April in any wood-heated home in a temperate climate. Fabricate a thin aluminum collar, a flat plate bent to contact the pipe surface, and mount your module array against it with the heat sink array on the ambient side. The stovepipe becomes your hot side. The room air becomes your cold side. You have a generating station that runs every single night the stove is burning, without any change to your routine, without any additional fuel, without any management at all. You were burning that wood anyway. The electricity is a consequence of physics, not an addition to your life, a recovery from something you were already doing. Thomas Johann Seebeck found this in Berlin in 1821 while looking for something else entirely. He found it in the junction of two metals at different temperatures, in a laboratory that had no electrical grid to connect to because the electrical grid had not been invented yet. He published it. The physics worked. It has worked without interruption for 203 years. The grid was built for the scale of the world that existed in 1936. The components for building around it cost $15 and fit in your shirt pocket. Seebeck didn't know what he had found. You do. The differential is still the engine. It always was. You just needed someone to show you where it lives.